The continuous function f is defined on the interval -4 is less than or equal to x, which is less than or equal to 3. The graph of f consists of 2 quarter circles and 1 line segment, as shown in the figure above. Let g of x equal 2x plus the integral of f of t d of t. First, we're going to look at the information provided by the problem, which is given in a graph of f, which is a piecewise function. The first part of the piecewise function is negative square root of 1 minus quantity x plus 4 squared, square root of 9 minus x squared. Y equals negative 2x. Information given to us by the problem is that g of x is equal to 2x plus the integral from 0 to x of f of t. Question. Part A. Find g of -3, find g prime of x, and evaluate g prime of -3. We'll start by finding g of -3. G of -3 is equal to 2 times -3 plus the integral of 0 to -3 f of t d of t. G of -3 is equal to -6 minus 9 pi over 4. Next, we'll solve for g prime of x. G prime of x equals 2 plus f of x. For the final part of part A, we need to solve for g prime of -3. 2. B of the problem, we need to determine the x-coordinate of the point at which g has an absolute maximum on the interval of -4 to +3. Justify your answer. To do this, we need to use the first derivative test. First, we need to solve for the critical values. To do this, we make g prime of x equal to 0. X equals 5/2. We will also need to look where g prime of x does not exist for our other critical values. G prime of x exists on the interval of all real numbers, so now we'll start our first derivative test using 5/2 as a critical value. Our first derivative test will set up a table with our intervals at the top. X equals 5/2 is an absolute maximum for g of x on the interval of -4 to +3. For part C of the problem, we will find all values of x on the interval -4 to 3 for which the graph of g has a point of inflection. Give a reason for your answer. To find a point of inflection, we need to find the second derivative of g, equate that to 0, find all possible points of inflection, and use the second derivative test. We'll start by finding the second derivative of g. Our second derivative of g is going to be equal to f prime of x. The x values that this equation is equal to 0 for is -4. This derivative does not exist for the x values of -3 and 5. These are also going to be used as possible points of inflection when solving with the second derivative test. However, we can exclude the value 5 because it does not fall in our interval -4 to 3. So x is equal to 0 is one possible point of inflection, and this equation does not exist when x is equal to positive or -3. However, we can exclude positive 3 because it does not fall in our interval, so we will only use -3. And that would be -2, which is not equal to 0. So we can exclude that from a possible point of inflection. Then we'll go on to use the second derivative test to solve for concavity. We're going to make a table similar to that of the first derivative test, and our points of inflection being used are x equal -3 and 0. So to make our table, we set up our intervals. So our point of inflection for g of f is x equals 0 because f prime of x, which is equal to g double prime of x, changes sign at x equals 0 in the second derivative test. Part D, the final part of this question, we need to find the average rate of change of f on the interval -4 is less than or equal to x, which is less than or equal to 3. There is no point C on the interval of -4 to 3 for which f prime of C is equal to the average rate of change. Explain why this statement does not contradict the mean value theorem. First, we will solve for the average rate of change of f on the interval of -4 to positive 3. -2 all over 7. This is our average rate of change of f on the interval -4 to 3. F of x is not differentiable at x equals 0 because there's a corner. That means this statement does not contradict the mean value theorem because it is not differentiable on the interval a comma b, or for our problem -4 comma 3, due to a corner at f of 0. You can find practice problems in the textbook in 4.1 and 4.4 for the first derivative and second derivative tests, 4.4 for points of inflection, 3.1 and 3.2 for derivatives. Chapters 5 and 6 cover many different topics of integrals and antiderivatives. Piecewise functions are something learned in a more basic class like pre-calculus and even algebra. Maximum and minimums, including absolute and local, in chapters 4.1. Mean value theorem and average rate of change have practice problems in 4.2, and the chain rule is discussed in 3.4. Thank you for watching.